That's great. That's something for the cafe, and we continue discussing it there. That's great. We're about 100% over time already. So we took 40 minutes instead of 20. And to be fair for the others, it would be right to just continue, because I'm also very curious about Thomas' talk.
Thomas.
Our next speaker, Thomas Göppel, and he's talking about an inquiry into an embedded standard force. And oh, you're already sharing your screen. So yeah, Thomas, please go ahead. The stage is yours.
Okay, so thanks for the scene. Can you understand me? Because my audio has been weak.
That's fine. Fine.
Good. Okay. I like inquiries. So it's from Peirce, who said the first rule of science: don't stand in the way of inquiry. So Ulrich last time showed a Forth package system, and I thought, well, this is worth considering. Okay, so let's check if embedded Forth can work with package systems. So first, what is an embedded system? You all know what embedded systems are, but I try a definition here. So that's usually, because we are talking about software engineering, self-contained software and hardware designed to add behavior, capability, or other properties to an appliance. So we're not talking about the software itself, we're talking about the appliance, right? The programming paradigm normally is you have some kind of physical input. It's not data. You do processing or state change, and you create some kind of physical output, a reaction of an appliance, something people can use or find useful. And the solution development is usually part of the appliance design process. It's one thing. Embedded systems should be ready to run unless they are defective or in need of intervention. So I want to avoid that. And there's a huge variety of specialized hardware. We just saw one, the Parallax. Microcontrollers, FPGAs, ASICs, system on chips. So you know them all. Why would one use Forth for embedded systems? Well, we just saw a very nice example for that. Why we would want to use that. So in my words here, it's interactive development close to the appliance. It's not close to the software. It's close to what we want to make act. You can do control loops or behavioral tuning in robotics. You can, programmer can develop a language of the appliance, and they can look at it from a symbolic or representational point of view, or directly from an emergence point of view, emergent behavior, like an evolution as a design cycle. You get seamless low-level programming and can interact directly with peripherals of the microcontroller. And it's easy to create a language that for what has a meaning in the context of the solution. So that's what I call machine semantics. The Forth community talks a lot about semantics. I do that too. So if Forth is so great, why doesn't everyone use it for appliances? Well, there's a lot of talk about that, right? In this meeting, I've heard a lot of discussions about it. I think in every discussion when our Forthers meet. Awareness, education, size of community. So when you're doing something about that, it's good. But there's something else. There's a lack of readily available solution elements. We want to do pattern matching, data structures, Arthur's bindings. You get it readily for C. You have to do it on your own. There's a culture of intellectual property instead of open source. And your Forth guys work in a small niche of specialists, much like HDL. So that's a problem. If nobody knows it, then it's because it all happens in a niche. Available code examples of Forth very often have unclear license terms. They look like they were in the public domain, but maybe they are not. And whoever uses that for an appliance puts the company at risk. It's a huge liability for business. Managers are very careful. Commercial solutions exist, of course, but not for the whole range of modern embedded hardware. And you don't want to be the one who loses out at the end, because the next hardware cycle is not supported by your niche environment. So, what's the solution? Sharing solutions. What's required? Successful ecosystems like Java, JavaScript, Node.js, everything around C, etc. thrive through sharing solutions, because you do not only share your solution, you also share the cost of maintenance because other people contribute. It's very expensive, it's not cheap to share solutions. What's necessary is source code repository. GitHub is very popular, I use it too. And there's a good old paradigm. You say, if something available out there, you either clone and own, or you push and thrive. So you do not want to lose connection to the community, right? Also, code quality is very important. Open source software doesn't meet the mark with very fast, not a good solution anymore. It won't be shared. The next thing is package repositories. So Ulrich showed the Forth.net. And there you have a different paradigm. Know what you depend on. So dependability of that is very important, but also things like dependency management and semantic versioning. There's also quite a skill set related to that. And then, of course, each of these ecosystems needs a shared factual standard programming language. So we have almost everything here, even a Forth standard. We have Forth.net. So can we start sharing embedded Forth code? In my opinion, there's a problem. We're not there yet. First thing, Forth was born on mini computers and mainframes. 70s, 80s, and 90s, small computers or hobby computers or whatever, Altair, or what these things, emulated big machines. Memory, floppy disk drives, terminals. So the cycle was essentially similar. The Forth standard makes still the same assumptions about the machine. Memory can be allotted, create, can be initialized and changed. Building data structures like list trees and graphs, that's for symbolic processing, very important things, the Forth way, depends on the Forth compiler interpreter in the system and a writable dictionary. So if you want to work high level, then this is what you want to use. this can create very, very powerful programs with very little memory, if you just saw. So now, microcontrollers, which were designed for appliances, for instant-on things, store the bulk of program code in flash ROM or another instant-on memory. And the ratio from RAM to ROM is not very good, 1:8 maybe. And it's most often a limiting factor. So you can run in a modern microcontroller like an STM32 F123, I don't know. It's a CPM machine with some quirks and tricks. So, but still it's just 20K memory, right? So quite powerful processor, still it's limited. So if you move the dictionary, Forth dictionary, to the ROM, it has huge implications. If you create A, like 1, 2, 3, create A, compile that to ROM, it will run fine. So you can check that value and get the table that you create at that point in the dictionary, but you cannot write to it. So if you write to that thing, you will get the old value. And this is a gap in embedded systems that limits the power of a Forth standard. As you remember, the Forth standard would be the thing that we need for sharing code. So, what can be done to use the power of Forth in an embedded system? Here is a modest proposal. First, talk about it. You're Forth experts, of course, a lot of interested new beginners. Experts easily understand what a dictionary means and what the relation between the source code and the dictionary is. Make sure that newcomers understand it and what the assumptions are. Learning Forth is not about 2, 3 plus. It's about the thing that's very close to Lisp, that owes itself to symbolic programming. Provide examples how embedded systems can be designed with and for Forth, based on assumptions, maybe about memory and the location of source code. Use plain language, because people who do not know the difference between the Forth paradigm and the C paradigm will not understand it. Then provide a reference implementation that is Forth ready. The ESP32 thing is very, very good because it already has sufficient RAM to do the things in the Forth way. But make sure that the source code can be an integral part of the embedded system. I've seen examples for that. It's very promising. Then, of course, you do not need everything in RAM. There are useful things with Forth you can do without a lot of RAM. I've got my famous little boards. This one arrived today from a friend. I use that board or such boards to control a boat, right? So like water supply, etc. So I received it today and I made it run in 20 minutes. I didn't know anything about it. So what you should do then, what we should do as a community, is classify the types of systems and the use cases for tethered Forth or microcontroller Forth with experiments in RAM. So if you look at the slides later on, you'll find a couple of examples. These two examples with ME-CRISP. And then maybe also for very powerful Forth systems, like with a modern microprocessor microcontroller-like structure, the ESP32. Then compare and classify memory target extensions for different Forth dialects for embedded systems, like the ROM and ROM bang in OForth, the create vcreate in WebForth, or the C data, I data, U data approach that was come from MPE Forth. So these are powerful things, like especially the last one. There's also a very low-key approach that I use in my small Forth dialect. And then, of course, it's also about creating an inclusive ecosystem. So it has to be practical. I was very impressed by the thing that Ulrich showed. It's important in an embedded system development environment to make such dependencies loadable from the development environment. So you can have a self-contained environment there. If you have network connection, the ESP32 has Wi-Fi. So why use that? And I'm using eForth.com. So it would be really cool to have such a functionality implemented in gForth and have the packet management system directly there. It would be cool. Then what about talking in a packet management system about hardware dependencies? One could declare such dependencies on memory allocation, etc., or hardware abstractions. It's also a good thing. I think that Peter talked about that, hardware abstractions for using sensors. It's interesting. So, and then, of course, also, there's a lot of interesting things out there. And innovation may come from really unexpected places. Don't crush it. So that's all. Thanks for your attention. I hope you have suggestions and questions.
Thank you very much. Yeah, I think that's all worth discussing. Thank you. So are there any questions to Thomas? So I see someone, thumbs up and clapping hands. Are there questions? Just